All right, here we go on question number 7, where we're going to have to use integration by parts again. And not only that, but we've been given an initial condition for exactly what we need to do here. So in this case, we're looking right up here to get our starting values. All right. So to get started with this guy, what we're going to do is multiply both sides of this equation by dx. And when we do that, that sets us up for our integration. So dy is equal to x e to the negative 5x dx. And because it's set up like this, we can go ahead and integrate. And when you integrate on the left, you get y. On the right, though, you've got to do integration by parts. And when I do that, I'm going to let u equal x. So du equals 1 dx. And I'm going to let dv equal e to the negative 5x. So remember, a pattern that has developed when we integrate e to the negative 5x, that takes a negative 1/5 and puts it in front and leaves the exponent alone. And why does that work? Because when I take the derivative of this guy, I get dv. And we could work that, we could also work it out over here. If I have e to the negative 5x dx, and I let u equal negative 5x, du is going to be negative 5 dx. And so negative 1/5 du equals dx. Now I went through all those steps really quickly, but when you make your substitution, you have e to the u times dx, which is negative 1/5 du. And now when I integrate that, I have negative 1/5 times e to the u plus c. And what is u? It's negative 5x. So we really like e to the x. He's really nice to work with. He gives us clean integrals and clean derivatives, okay? So now I follow my pattern, which is going to be u times v, and when I do that, I wind up with negative 1/5 x times e to the negative 5x, and then minus the integral of v du. So the integral of these guys right here, which is basically going to be negative 1/5 e to the negative 5x dx. Not too bad, not too bad. Just take one step and clean it up. I'll write it all in black this time. So negative 1/5 x e to the negative 5x. And I have a constant here, so he can come out. And it looks like this. The cool thing here is we've already integrated e to the negative 5x. That's that guy right there. So when my next step is performed, that first part stays the same. But now I have 1/5 times negative 1/5 e to the negative 5x plus the c now. And so the actual problem that we're working with, when we clean all this up, the actual problem we're working with is y equals negative 1/5 x e to the negative 5x minus 1 over 25 e to the negative 5x plus c. Now, since we were given an initial condition on this, y is 9 when x is 0, we can substitute all those values in. And I'll do that right down here in the number 9 spot. So when y is 9, so I'm just going to make that substitution right now. There's no trickeration going on. There's no look at the left hand while the right hand does some funny business. And what happens is this term goes away because you get 0 times all those numbers. And e to the negative 5th times 0, that's 1. So this guy goes away, and we're just left with 9 equals negative 125 plus c. So you're going to add 1/25 to both sides. Let me just double check. And I get 226 over 25. So, which is what your answer says, 226 divided by 25. And all that means is, let's see, we don't need these guys anymore right here. All that means is that my solution for this problem is y equals negative 1/5 times x e to the negative 5x minus 1 over 25 e to the negative 5x plus 226 over 25. That's your final answer on question 7. That's a pretty detailed problem, but again, it's not horrible, and the integration is pretty reasonable.